Hello, everyone, and welcome back to Algebra 1-2, where we discuss topics in Algebra 1, Algebra 2, and additional mathematics. And in this lesson, we are looking at how to factorize using the difference of two squares. Very interesting. And so, in this lesson, we will learn how to factorize an algebraic expression, which is the difference of two squares. Before we get into that, we need to talk about a few things. First, we need to talk about the difference idea here. Difference idea here simply means minus. And since we have two squares, now we need to talk about square numbers and the square terms. Now, what are square numbers? Let's take a square, for example, and say it has a unit of 1 length. Then if we want to find the area, then the area would be 1 times 1, which is 1. And that is a square number. So 1 times 1, 2 times 2, 3 times 3, etc., etc. So that's 1, that's 4, that's 9. And that is how we get our square numbers. Continue on 4 times 4, 7 times 7, etc. That's how we get our square numbers. So this is a set of square numbers going on. And when we talk about square terms, we simply mean square terms that have an even power or have a power that is an even number. So here we have 2 or 4 or 6 or 8 or 10. As long as it's an even number, we consider it a square term. All right. Before we start factorizing using the difference of two squares, I want us to look at this expression first. I want us to multiply it out, use the distributive law to multiply it out and see what we get. So we have 3x plus 2 and 3x minus 2. We want to expand and simplify that. So we're going to write it out using the distributive law, 3x multiplied by 3x minus 2, and that plus 2 here multiplied by 3x minus 2. Now let's multiply here. 3x times 3x gives us 9x squared, minus 3x times 2 gives us a 6x here. And 2 times 3x gives us a positive 6x there. And 2 times minus 2 gives us a minus 4 there. So we can simplify in the middle. These are like terms. This is unlike, but these two are likes, and that is a 6x take away 6x. That leaves us with a 0. So we can write back our answer as 9x squared minus 4. That's our answer. So the question is then, if we wanted to reverse this, how could we reverse it so that we get back this expression for our answer? And remember, to factorize is to rewrite a sum or a difference such as this in product form, like that. So how could we reverse this? So if we were asked to factorize 9x squared minus 4, there is fortunately a shortcut way that we can use to get our result. First, we need two brackets like that. And then we need to look at these terms. Now, notice that 9 is a square number. Notice that x here has an even power, x squared. So it's a square term. And notice that 4 is also a square number. And what is the square root of 9? The square root of 9 is actually 3. And the square root of x squared is actually x. So remember, x squared means x times x. So if you want to find the square root of x squared, you're actually finding the square root of x times x, such as finding the square root of 5 times 5. Remember, the square root of 5 times 5 is the same thing as the square root of 25, and you know that the square root of 25 is 5. So the idea here that the square root of x squared is just x, and the square root of 9 is just 3. So we can write that as 3x here and write it also in this bracket, 3x. And then we write our one bracket b plus, one bracket b minus, and then we find the square root of 4. Now the square root of 4 is also 2 and 2. And this is the shortcut way in which we can use to factorize the difference of two squares. What do? We take the square root of each term, write it in the bracket, and simply put one bracket plus, one bracket minus, and that's it. Now let's practice it. So here we have 9 minus 25m squared. Let's make that a little bigger. 9 minus 25m squared. And so this is a square number. This is also a square. Everything here is square. Notice that we have a minus in the middle. It has to be minus. And so we put our bracket and we find the square root of 9. What is the square root of 9? The square root of 9 is 3. We simply write it there. Make one bracket plus, make one bracket minus. Square root of 25m squared turns out to be just 5m because the square root of 25 is 5 and the square root of m squared is m. And that's it. It's actually finished. We're done. That's the answer. Nothing else to do with it. Here we have another one. Let's make it a little bigger for the purpose. And remember, we're simply going to need two brackets. So it's very quick and easy. We find the square root of this term, which would be 4g. The square root of 4g squared rather, which would be 2g. So 2g goes there, 2g goes here, and the square root of f squared is f. Make one bracket plus, make one bracket minus, and we get our answer. That's it, actually. So it's a very, very interesting idea, very, very interesting to use. And let's look at some more examples. Sometimes, though, our question might be hidden, such as this. So it might say factorize completely 3 minus 12b squared. Now, as is, the b is a square term, but 3 is not a square number, neither is 12. What we can do first here is to apply the HCF. So let's apply the highest common factor first, and when we do that, which is 3, we end up with 3 divided by 3 is 1, minus 3 into 12 is 4, b squared. So sometimes the idea there is a bit hidden. Once you divide by the highest common factor, you see that it's actually the difference of two squares, and now we need two brackets. And so we go, the square root of 1 is 1, make one bracket plus, make one bracket minus, the square root of 4b squared is 2b, and we're finished. Next, here are two other examples that look a little different. So first we look at this one, same idea. This is a square term, this is also a square term, and what we're going to do then is to take two brackets. Now, it's 1. So I'm using a different bracket here. You'll see why in a moment. So 1 minus the square root of this, which turns out to be a plus b, and 1 plus a plus b. Now, in using this one, notice that when we remove this bracket here, because of this minus sign, this is going to become a minus a and a minus b. So we write 1 minus a minus b, and that is good. And then we write 1 plus a plus b, and we're through. That's simply it. So like I said, it's a very, very interesting idea. It doesn't take a lot of work. It doesn't take a lot of understanding to do. Here we have another one, 2x squared, 2x minus y, all squared minus 9. So we're just going to go ahead and write it down. Let me use a different ink on this side. So we're going to have our two brackets. And the square root of this is simply 2x plus y, 2x plus y, write the same thing in both brackets, and the square root of 9 is minus 3 and plus 3. And that's simply it, and we are finished. Sometimes, though, it's not so obvious again, such as this, e to the 2x minus 1. And the 2x doesn't look like a square term, but it actually is. Now, from indices, we remember that if we're multiplying e to the x times e to the x, then we actually add the powers when we have similar bases, so it becomes e to the 2x. So e to the 2x is actually a square term. And what we do then is to do the same thing that we have done before. We open two brackets and say the square root of e to the 2x is simply e to the x. Write that first, and the square root of 1 is 1. Make one bracket plus, make one bracket minus, and we are through. Here we have another one again. Here we have a 4 instead, and not the regular 2. So let's open a bracket. Now the square root of x to the 4th. Remember now, x to the 4th is actually equal to x squared times x squared. So the square root of x to the 4th is actually x squared. Remember, when you're finding the square root of a number, you're asking yourself, such as 5 times 5 equals 25. Which number multiplied by itself gives me 25? And so the square root of 25 would be 5. Now, if x squared times x squared gives you x to the fourth, then by that same reasoning, the root of x to the fourth is actually x squared. So we're going to write that down. X squared plus the square root of 1 is 1, and x squared minus 1. And it almost looks like we're finished. This part is not the difference of two squares, but this part out here actually is the difference of two squares. So we can apply the same technique to this part again by writing x squared plus 1, and then 2 more brackets for this part. We're going to break this into x plus 1. The square root of x squared is x, and the square root of 1 is 1. And that would be our final answer for that. Beautiful. Now let's look at one final example. And I have been saying so far that you need square letters, you need square terms, and you need square numbers. In general, though, you can apply this technique even if you do not have square letters or square terms and square numbers, as long as you have a difference in between them. So factorize x minus 2. And this can come up later on in some questions where you're working out limits and stuff, and you need to do some quick factorization. And so if we have x minus 2, and we want to factorize it, then we're going to follow the idea. So if we have a squared minus b squared, and we want to factorize it, then what we do is that we take the square root of a squared plus the square root of b squared, and also the square root of a squared here minus the square root of b squared. And so we just apply the same idea here, open two brackets. And what is the square root of x? We don't know, so we just write square root of x. And what is the square root of 2? Make one bracket plus, make one minus. Square root of 2, we simply write square root of 2. And that would suffice for our answer. So we can use this idea, and without having the square, we can still apply it as long as there is a minus in between them. Remember that you need to go find some questions now and practice this skill. Practice until you get it. Practice so that you can't forget it. And of course, if you haven't subscribed to our channel, then I ask you please to do so before you go. And of course, thank you so very much for watching.